A quadratic sequence is a sequence with a constant second difference. So a linear sequence has a constant first difference, and a quadratic sequence has a constant second difference. Once we determine our differences, so whether it's a constant first difference or a constant second difference, we're going to then substitute into our formula to determine the nth term. Once we determine the nth term, we are then able to calculate any term value within that sequence, or we're also able to determine whether any value is in the sequence or it would fall in the sequence at a later point in the sequence. When we're talking about a quadratic number sequence, what we're talking about is in the form Tn equals an squared plus bn plus c. So that's the same form as a quadratic equation, a quadratic expression. We have a quadratic sequence. Tn equals an squared plus bn plus c. Alright, if we have the sequence 4, 10, 20, 34, and 52, we want to determine our general term or our nth term. So we're going to start by determining our first difference. So our first difference will be term 2 minus term 1. 10 minus 4 is 6. 20 minus 10 is 10. 34 minus 20 is 14, and 52 minus 34 is 18. We can see that we don't have a constant first difference. So now what we're going to do is we're going to determine our second difference. So same thing, term 2 minus term 1. So 10 minus 6 is 4, 14 minus 10 is 4, and 18 minus 14 is also 4. So now what we're going to do is we're going to circle our first term of each of our rows. And then we have our formula that we need to know. So our formula that we're going to learn, the bottom one is 2a is equal to the first term of the second difference. Then I have 3a plus b equal to the first term of the first difference. And then my third equation is a plus b plus c is equal to our first term in our sequence. Now what we're doing with this a, this b, and the c is we're determining the letters that go into our formula. So in our standard form, Tn equals an squared plus bn plus c. But now we have three different equations. So we're able to first determine a, use a to determine b, use a and b to determine c. So I'm just going to quickly write out these formulas. So I have 2a equal to 4, 3a plus b equal to 6, and then we have our last one, which is a plus b plus c equal to 4. So if I have 2a equal to 4, I want to get the a by itself, so that means that I'm going to divide both the left-hand side and the right-hand side by 2. So therefore, a is equal to 4 divided by 2, which is 2. Now I have an a value of 2, so I can substitute that into my second equation. So now I'll have 3 times 2 plus b equal to 6. So 3 times 2 is 6, plus b equals 6. So to isolate the b, I'm going to take the 6 across. So therefore, b will equal 6 minus 6, which is 0. So now I have a b value being 0. So I can put the b value in place of the b. I can put the a value in place of the a. So a is 2, so 2 plus b is 0, plus c is equal to 4. So 2 and 0 is 2, plus c equals 4. So therefore, c is equal to 4 minus 2, which is 2. Now I can substitute this into my formula. So my general term is Tn is equal to an squared plus bn plus c. So a is 2, so 2n squared plus bn, b is 0, so I'm just going to leave it out, plus c, which is plus 2. Alright, if we look at our next example, we have 8, 17, 32, 53, and 80. So we're going to start by determining our first difference. So term 2 minus term 1, term 3 minus term 2, etc. So 17 minus 8 is 9. 32 minus 17 is 15. 53 minus 32 is 21. And 80 minus 53 is 27. So we can see that we don't have a constant first difference, so now we're going to look for our second difference. So for our second difference, 15 minus 9 is 6, 21 minus 15 is 6, and 27 minus 21 is also 6. So now we have a constant second difference. So now I'm going to circle the first term of each of my rows. My formula, 2a is equal to the first term of the second difference. 3a plus b is equal to the first term of the first difference. And a plus b plus c is equal to the first term of the sequence. Now I have 2a equal to 6. I have 3a plus b equal to 9. And then I have a plus b plus c equal to 8. So if I have 2a equal to 6, what I'm going to do is I'm going to divide both sides by 2 to get the a by itself. So therefore a is equal to 6 divided by 2, which is 3. Now I take that a equals 3 and I replace the a with it. So I have 3 times 3 plus b equal to 9. So now I have 3 times 3, which is 9, plus b equals 9. So therefore, b is equal to 9 minus 9, which is 0. So now I take the a value, put it in place of the a. I've got a b value, which is 0. I'm going to put it in place of the b. So what I'm going to have is 3 plus 0 plus c equal to 8. 3 and 0 is 3, plus c equals 8. So therefore, c is equal to 8 minus 3, which is 5. Now I can put these values, the a, the b, and the c, back into the formula. So Tn is equal to an squared plus bn plus c. So Tn is equal to an squared, so 3n squared, plus bn, b is 0. So I'm going to leave it out, plus c is 5. Alright, I'd like you to pause the video, minus 1, 5, 15, 29, 47, and you're going to determine the nth term. Alright, now that you've paused your video, you've had a go, here is the answer to the sequence. We have 7, 12, 19, 28, and 39. So our very first step is we're going to start by determining our difference, the same as we did with our linear. So we do term 2 minus term 1, term 3 minus term 2, etc. So we start with term 2 minus term 1. 12 minus 7 is 5. Term 3 minus term 2. 19 minus 12 is 7. 28 minus 19 is 9. 39 minus 28 is 11. So we can see that we don't have a constant first difference. So what we're going to do now is we're going to look for our second difference. So our second difference, we work the same way. We do term 2 minus term 1. So 7 minus 5 is 2. 9 minus 7 is 2. And 11 minus 9 is also 2. So now what we're going to do is we're going to circle our first term in each of our rows. So we circle the 7, the 5, and the 2. And now we need to know our formulas or our formulae that go with each of these terms. Alright, so now we have 2a equal to the first term of our second difference. We have 3a plus b equal to the first term of our first difference. And we have a plus b plus c equal to the first term of our sequence. So now what I'm going to do is I'm just going to rewrite my equation. So I have 2a equal to 2. I have 3a plus b equal to 5. And I have a plus b plus c equal to our first term of our sequence, which is 7. So now what we're going to do is we're going to start by solving for a. Then once we have an answer for a, we will be able to get rid of the a in each of the formulas. Then we do b, and then we determine c at the end. Alright, so if I have 2a equal to 2, I'm going to divide both sides by 2 to isolate the a. 2a divided by 2 is a, equal to 2 divided by 2, which is 1. Now I'm going to take a equals 1 and I'm going to put it into my next equation. So I have 3 times 1 plus b equal to 5. So 3 times 1 is 3 plus b equal to 5. So therefore b will equal 5 minus 3, which is 2. Now what I'm going to do is I'm going to take this b equals 2 and I'm going to replace the b with the b. So I now have a being 1 plus b being 2 plus c equals 7. 1 and 2 is 3 plus c equals 7. So therefore c will equal 7 minus the 3, so c equals 4. Now I have a equal to 1, b equal to 2, c equal to 4. So I can now write out my nth term in the form Tn equals an squared plus bn plus c. So a is 1, so I could either write it as 1n squared or I could leave out the 1 plus bn, b is 2, n plus c, c is 4. So I have Tn equals 1n squared plus 2n plus 4. Alright, I have 6, 13, 24, 39, and 58. So I'm going to start by determining my first difference. So that's term 2 minus term 1, term 3 minus term 2, etc. So 13 minus 6, which is 7. 24 minus 13, which is 11. 39 minus 24, which is 15. 58 minus 39, which is 19. So we can see that we don't have a constant first difference, so we're going to go to our second difference. So we have 11 minus 7, which is 4, 15 minus 11, which is 4, and 19 minus 15, which is also 4. So now I'm going to circle my first term of each of my rows. So I have 2a equal to the first term of the second difference, 3a plus b equal to the first term of the first difference, and a plus b plus c equal to the first term in the sequence. So now I have 2a equal to 4, I have 3a plus b equal to 7, and I have a plus b plus c equal to 6. So if 2a equals 4, what I'm going to do is I'm going to divide both sides by 2. So therefore, a is equal to 4 divided by 2, which is 2. So now what I'm going to do is I'm going to take this a equals 2 and I'm going to replace the a with that 2. So it'll be 3 times 2 plus b equal to 7. 3 times 2 is 6 plus b equals 7. So therefore, b will equal the 7 minus the 6, which is 1. Now I have a being 2 and I have b being 1. So I can put the b's 1 in place of the b and the a's 2 in place of the a. So I have 2 plus 1 plus c equal to 6. 2 and 1 is 3 plus c equals 6. So therefore, c will equal 6 minus 3, which is 3. I have a, I have b, I have c. So therefore, I can substitute it into my nth term in the form Tn equals an squared plus bn plus c. So Tn is equal to an squared, a is 2. So 2n squared plus bn, b is 1. So I can say either 1n or just n plus c. C is 3. Alright, now I'd like you to pause the video please and attempt these two sequences by determining the general term or the nth term for both of them. We have 6, 15, 26, 39, and 54, and we have 3, 13, 27, 45, and 67. Now that you've attempted both of those questions and you've determined the nth term for both of those sequences, here are the answers.